Welcome, everyone. We'll get started here in a couple of minutes. Thanks for joining us today. All right, well, let's go ahead and get started. Brad, if you don't mind going to the next slide. Just wanted to say welcome and good afternoon. My name is Lisa Hans, and I'm the Director of Programs at the Alliance for Water Efficiency. And we are very excited today to bring you this webinar showcasing the suite of tools and resources related to cooling technology. Got a great turnout today, and we want to save time at the end for questions, so we're going to jump right in. Next slide, please. So the webinar is an hour. Attendees are muted, and this is being recorded so that folks can go back later and rewatch if they choose, or if they couldn't join us today, they can rewatch. You can type questions through the webinar platform here throughout, and we will address at the end. Next slide, please. I have two wonderful guests with me today, Maureen Arbuznek, who has extensive experience with cooling towers and is a leader in water and energy efficiency. She's helped to design and implement and assess efficiency programs over her extensive career, and she's been an indispensable program manager on this effort and has helped brought the how-to and practical tools to life. She'll also be sharing a case study with us today. Sam Fetter is a water use efficiency analyst with the water use efficiency team at the Municipal Water District of Orange County in California, and has been a great partner in exploring the opportunities to reduce water use through cooling. He presented last year on a webinar that we did related to one of the tools you'll hear more about today, and he's here back again to provide an update on their effort using the AWE tools. Next slide. The Alliance for Water Efficiency is a nonprofit. We're focused on the efficient and efficient and sustainable water future. We're really the only organization that's solely dedicated to the strategies and to the people who work to use water wisely and create more resilient communities. So being a member is really a commitment to help advancing action, creating new knowledge, bringing together ideas and stakeholders, and joining an incredible network of professionals. So becoming a member grants you access to the tools and resources you'll learn about today, among many others. Next slide, please. So today we're going to cruise to start with at the 30,000 foot level for a little bit. I'll provide some basics of why cooling is an important thing for the water sector and the basics of what a cooling tower is. We'll share a little bit about this multi-year project and then cover the resources and tools that it has generated. Mo will provide a short case study to show you the potential for water savings, and then Sam will dive deeper on how his organization has used the AWE tools as the foundation for their efforts and show the steps they've been taking to build upon that foundation. Finally, I'll share an exciting announcement that we're launching the application period for our very first learning cohort. So more to come on that, and I will point out that we did have a webinar. It was last April. You can find it on our website. That was just about the CTEM tool. So just an additional resource if you want a deeper dive on that specific tool. AWE staff is always here to provide technical assistance or answer questions on these and other tools for our members, so don't hesitate to reach out. Next slide, please. So cooling is certainly catching up with us. Populations are growing, increasing the demand for space cooling. Economies and businesses are growing and changing a lot processes require cooling. We're seeing facilities like data centers popping up all over the place, increasing the demand for cooling, and largely this cooling uses water. Further, climate change is increasing the number of hot days and the length of heat waves, and we have long known that cooling towers use a lot of water, but have struggled to turn this fact into action. The good news, though, is that you don't need to be a technical expert in cooling towers to have an impact. Next slide, please. So just to give everybody the same foundational basics today, what is a cooling tower? Cooling towers are ways to remove heat from a building or a process through evaporation. So they cool people and spaces and all sorts of hot processes. That water is exposed to air and transfers that heat by a portion of the water evaporating. So on this very simple graphic, I'll just highlight a few key terms. The makeup water. So this is typically the total water use. This is the water that is going into the system and gets added in. This is the source water, which is often potable water, but it could be alternative water sources or a combination thereof. The water that is consumed by a cooling tower is the water that is evaporated. When the water evaporates, the remaining water has a higher concentration of total dissolved solids. So this is where water quality comes into play. The blowdown or the bleed is the water that is removed from the cycle. This water is the water that has a higher concentration of dissolved solids. So as that water is evaporated, more and more solids build up in the water. And so some of that has to be removed and some new cleaner water, the makeup water, is added. So this is the key metric for water efficiency, is the cycles of concentration. So we can't infinitely let solids build up. So we do have to balance other issues like managing scale buildup, corrosion, biological growth, and more. So really, typically the main focus to achieve water efficiency is to increase the cycles of concentration by reducing the blowdown and therefore reducing the makeup water needed. Next slide, please. This equation helps highlight what I was just talking about, but I'll also point out two other sources of water use or water loss. Drift, which is in the nature of kind of open circulating systems, is that some water gets lost to those water droplets that are being sprayed getting blown outside of the system rather than going back into the recirculation. So think about like a fine mist irrigation system that's blowing in the wind. Some of that water isn't getting where you need it to go. But there are ways to minimize drift. The last source I'll point out is water loss that might be due to leaks or overflow. So just like in the back of your toilet, that little lever on a float valve can sometimes be causing the system to continuously fill. You might have leaks or issues with nozzles. So there's other ways that you can manage water waste in a cooling tower system. Next slide, please. So the solutions, and these are things that are identified in the tools and the resources that we'll talk about a bit more, but I'll emphasize the first, that ideally as a society, we can help reduce the demand for cooling in general and avoid unnecessary use for it. That'll be a win for everyone. These tools and resources don't necessarily get into these types of solutions. They're more into the second set of solutions where when you do have a cooling tower in place and you want to explore means to effectively manage the water demand. So largely this is going to be through monitoring and tracking things, just having a better handle on the whole system, as well as managing the water quality so that you can have higher quality water in the system and therefore reduce the blowdown and reduce the water that you need to add. You can also explore incorporating other water sources in your system, like capturing condensate from air handling units. And then finally exploring alternative technologies that require less water altogether. Next slide, please. So those are the basics, just to give everybody the same foundation. So the Alliance for Water Efficiency is a forum for stakeholders to discuss opportunities and barriers across all things water conservation and efficiency. We know that there is a lot of opportunity in cooling towers, but there's also a lot of barriers. Here's just a few of the questions that we were hearing from folks who either work for water utilities or other organizations who are truly trying to reduce water use. They recognize that cooling towers could be a great way to do this, but there were lots of challenges in getting to action. So these conversations came up in our research committee, which is one of the many ways that we help generate ideas for AWE projects. So this helped lead to the creation of what you're going to hear about today, the Cooling Technology Project. Next slide, please. So the goals of this multi-year project were to help folks first find the cooling towers in their community. Second, to estimate the demands for cooling, both consumptive and non-consumptive, to determine what the conservation potential and therefore the water savings from efficiency improvements could be, explore alternative technologies to traditional cooling towers, and then ultimately create practical tools to help water providers and other consultants and folks who are working in the space to build effective programs and services. Next slide, please. I, of course, must do a shout out to our incredible project team. We had a whole suite of folks from Pacific Northwest National Laboratory. Brian and Tyler were our key technical experts and the builders of the tools you'll hear about today. Mo has been an advisor and a project manager and the creator of our practical tools. And of course, the incomparable Bill Hoffman, who lent his many years of experience with cooling towers. And of course, while I'm lucky to be here to shepherd this project over the finish line, there are many AW staffers who were integral to this project over the years, including Marianne Dickinson and Bill Christensen. Next slide, please. And we could not have done this without the generous support of our members. There's not a lot of funding for research in the water conservation and efficiency space, so we can often rely on our members to help us identify the ideas and then help offer the funding to create the tools and the resources for our entire network, and of course, members who join in the future. So thank you for your support and being part of the advisory committee that helped guide this project over the years. Here are the resources that were developed to address those project objectives. The first column is CTEM, or the Cooling Tower Estimating Model. This is what you're going to use to assess the market in the area. This is what you're going to use to figure out how many cooling towers might there be. Are these a lot of large facilities, or is it more smaller commercial type facilities? How much water could we potentially save by addressing cooling towers? You'll be able to explore any water quality limitations or options there, and ultimately also help you start and then continue to refine your cooling tower inventory. The second set of tools there, the how-to guide and the audit form, these are our practical programmatic tools. Mo created a beautiful how-to guide with the basics of water quantity, water quality, water treatment, suggestions for how to build a successful program, lots of program examples, designs of different options of ways to create the incentive structures, links to real programs that live out there in the real world. And finally, the team built an Excel tool that you can use as part of an on-site or a virtual audit. It has an ROI calculator to compare the return on investment of various options that you could take to reduce water use. These tools can really help you get in the door and demonstrate the business case to your customers. Finally, we hope the market continues to embrace technologies that don't rely so heavily on water for cooling. And our members really wanted to explore the alternative technologies. So we have a report that explores the 4 most commercially viable in depth. This also has a little case study from SAWS. They also created a tool that's a companion for CTEM where you can transfer some of your outputs from CTEM and then compare different scenarios of adoption of different technologies and practices. So really for future planning and exploring what you might want to help encourage the market to move in a certain direction. Next slide, please. Here's a little bit more about CTEM. So the main model here, the beautiful thing about this is it requires very few inputs to get started. It generates an auto-populated list of large sites, so coming from some national databases, and then it estimates based on a regression model the number of additional commercial sites and the cooling towers that might be in place there. Then there's a module for you to add your own data and to keep refining all of the estimates. So as you add your own data in and verify where there are and aren't cooling towers, you can continuously update the estimates for water savings through your efforts. So this is a really fantastic tool and a great place to start. And Sam will show you a little bit later about how they've been using it in Orange County. Next slide. Here's just an overview of the alternative technology resources. Here's the list of the 4 technologies that were selected for the report. The report includes a whole list of the other ones that were considered, but these are the 4 that were selected for a deep dive. It includes a case study highlighting the use of the comparing alternatives tool in the San Antonio system. Next slide, please. Yes. And then here are some nuggets of what you'll find in the how-to guide as well as the audit form and the return on investment calculator. So the how-to guide is covering the cooling tower basics, similar to what I touched on today, talking about water treatment and maintenance, which is typically the type of folks that are interacting with cooling towers at a building. Talks about the different strategies you might do to improve water efficiency, different considerations for when you might choose one over the other, cost considerations, other things like that. And then some practical tips for how to build a successful program and how to manage through the barriers that exist. It includes a lot of different tips, for example, suggesting different organizations that you might partner with who are also interested in cooling towers or might have good contacts for you, like energy companies or wastewater utilities, public health departments, and more. So this is a really great resource, lots of real world programs and examples for you to explore. And then of course the audit form, this is an Excel-based tool. You can use this in visiting sites or talking with customers over the phone, gathering some simple information. And then there's more functionality to it where you can explore different treatment options to help reduce water demand and improve efficiency there. Next slide. And then now we're going to jump into a case study to demonstrate just how much water can be saved by addressing water use in cooling towers. So I'm going to hand it over to Mo.
Thanks, Lisa. That was an amazing overview. You made it seem so simple. Next slide. You know, as Lisa stated, cooling towers use a significant amount of water, so they represent a huge opportunity for water savings. That's if you have large commercial cooling load in your service area. There are areas that there won't be an opportunity, but there are significant areas, probably most of you that are on the call today, that actually that do have the opportunity. An average cooling tower upgrade equates to about, let's say 1 million gallons per year savings. That would translate to 300 toilets or somewhere around 30,000 square feet of turf, depending upon your service area of turf replaced. So the opportunity is huge, but it also requires going in with your eyes open. And I wanted to share a case study that we did in LA City Hall East. So the city had set some really aggressive sustainability and water reduction goals. And they'd done toilets, they'd done turf replacement, but they were mandated by the mayor's office to further reduce use. And a huge opportunity for them was looking at their cooling towers. They had 17 properties with cooling towers that were being operated somewhat inefficiently. A couple of them were on the efficient range, and many of them super inefficient. And they also had goals to get off chemicals and just overall sustainability improvement. So when you're looking at this project, we went in, it's the LA Better Buildings Challenge, to help them evaluate what options that they had. And I really find cooling tower projects or marketing and outreach very similar to large landscape and commercial facilities. There's a lot of stakeholders. There's owners, property managers, facility managers, chief engineers, service companies, all of these folks that are either decision makers or influencers. And you really have to understand that it takes time, that these folks, it's going to take them time to do assessments, to do decision making, the planning, the budgeting. So the process takes a while. Even when we're looking at this city project, when they were, they had already made a commitment to the water reduction goals, it still took us a year to actually get the project approved. We had to meet with numerous facility folks from their general services department, simultaneously with the mayor's office. And what we decided to do was introduce a pilot concept so that it wouldn't be so overwhelming for some of the facility folks that maybe weren't ready for a new technology. We also included enrolled the National Renewable Energy Laboratory to do the actual evaluation, measurement, and verification of the project so that we could have a third party really endorsement of the chosen technology. And we selected dynamic water technologies. Next slide. So dynamic water technologies is an electrochemical water treatment. And it basically uses partial electrolysis to change the chemistry of the water so that you can actually increase the cycles of concentration. We implemented the pilot over a period of a few months and saw tremendous results. The first year, 20% water savings, 1.6 million gallons, 85% reduction in sewer costs, $34,000 reduction in utilities, water, sewer, and as well as chemicals. And they eliminated almost all the chemicals because the electrochemical treatment creates a water chemistry where you really don't need to add any chemicals, and including no biocides. Now, many customers, including the city, were not comfortable with moving completely away from controlling for biological growth, so they've continued to add the biocide. And then the plan was then to scale it, to install it in the majority of their other facilities where the economics made sense. And then COVID hit. Obviously, they had budget reductions, they had occupancy issues. So the full implementation has been put on hold, but the plan is still to do it at some of their larger facilities. And the drought also has impacted the actual water savings at the site. And this is one of the reasons, as with any landscape project as well, that you need to continually follow up with the customer. There are different parameters. The water quality has gone down at the site, so they've had to lower the cycles of concentration. Once it improves, they will increase it up, but it does require staying in touch with the customer to make sure that you're getting the continual savings. But it's a really, it is a very, I would say that this is very representative of a project that when you are going out to market your program to, that would be very similar. You're going to have to hit a lot of people. You're going to have to make sure that you address their specific pain points or value, what they value. And it's going to take a bit of time, but the savings can be in the millions. And in a standard office building, 50% of the water can be used in a cooling tower. In industrial processes and refrigeration, even more. So the opportunities there, you just need to go in with a planned process. I think there's a lot of great information in the how-to guide on how you can approach each of these different set of individuals with what type of messaging, where you can locate them, as well as some tools to help them assess the opportunity. And that's it on this side. I'm going to turn it over to Sam now.
Thank you, Mo. And hello, everyone. My name is Sam Fetter. I'm with the Municipal Water District of Orange County, also known as MODOC. And I'll go ahead and present on our experience with the cooling tower estimating model, also known as CTEM, an update on our findings that we talked about last year, and then what we're looking to do next. Next slide. And go forward just one more. All right, so a little bit about MODOC. If you're unfamiliar, MODOC is a wholesale water supplier and resource planning agency in Southern California. So we cover a lot of different water agencies, and there's pretty big variance in their customer base. Some have a lot of commercial customers, some it's basically all residential and large homeowner associations, and we'll see how that plays a factor a bit. Next slide. And so this is just a quick screenshot of the CTEM model, one of the data input pages. You can see there's some information here about the category, facility type, as well as the name and the address. The second column there is data that I had put in the has a cooling tower yes or no column. So I had two main data sets, and I went through and visually inspected 880 sites. And if I found a cooling tower, I could confirm there was a cooling tower present at the site, at least one. I marked it as a yes. If I didn't see one, then I marked it as a no for not confirmed. And so you can go to the next slide, and we'll see kind of what the aerial imagery looked at. So I did it all via aerial imagery, mostly on Google My Maps, some on this imagery called EagleView, which is 3-inch imagery. that I had access to. On the left here, this is confirmed positive sites. So these were sites in the CTEM model that it thought might have cooling towers, and they did. So at the top left here, this one's kind of hard to see, but there's a smaller cooling tower hidden to the side of the building. Some were kind of hidden, you had to really look for. At the bottom left here, this is a screenshot of a portion of Disneyland, which you can imagine has a lot of cooling towers around. So these were pretty easy to spot. On the right side is a site that the CTEM model, the data had in there as having a cooling tower possibly, and it did not. So the top view is using Google My Maps, and that bottom view picture is the same building, but with that eagle view imagery I mentioned, which is higher quality, and you can look around all the sides of the building. So if I didn't see a cooling tower, I tried to look around, really make sure I just couldn't see one anywhere. Next slide. And so here is a map. This is basically the findings. All of these red markers are sites where I confirmed had at least one cooling tower. And these yellow markers are sites that were in the data list, but I could not confirm cooling towers. There's also some blue markers here, and those sites also had cooling towers. I'll kind of go into detail at the very end as to why they're blue. But this is how it turned out. And we can go to the next slide here to compare the different data sets. So this first list is called the auto population list, or AutoPop. And this was just what came with the model, and it comes from like national databases. On the right here is the user input list. And this was something actually Maureen helped us with from a CoStar database. So I filtered it down to the sites it predicted had a cooling tower, down to the yes sites, and then I worked with it from there. So you can see a pretty big difference here. The AutoPop list has a lot less red markers, which were the yeses, confirmed cooling towers, and a lot more no's, the yellow markers, which are sites I didn't see cooling towers. So that was a pretty big difference in the list, and it kind of goes to show good data in, good data out. But both of these are also unique. So there were a few duplicates that I'd removed before inputting the user input list, but most of these red markers on the AutoPop list, even though that site had a lower accuracy of prediction, weren't in the user input list, which was more the more accurate kind of predictions, but neither list contained all the sites, so it's good to find more data if you think there's more out there. And you can go to the next slide here. This will kind of show some of the issues with that AutoPop list. It did have facility types categorized, but it had some kind of questionable sites in there. You can see here there's like an oil field and this undeveloped lot that were both in the list based on their facility type, and they didn't have cooling towers, and some projects like that undeveloped lot were just kind of nothing there, not built out yet. On the right were some sites that the AutoPop list had missed, and so these had pretty clear, obvious cooling towers, and it missed some of the hotels, large commercial buildings, big banks, and again, that user input list, which came from that CoStar database, really was more accurate and had a lot more of these kind of big cooling tower sites. So you can go to the next slide. And this is back to the combined data. Okay, so this is the AutoPop list and the user input list combined, just for Orange County. This actually isn't showing all of Orange County. Like I said, there's a pretty big difference in our retail agencies and their customer base. So I have most of the southern portion of Orange County cut off here. There were maybe a couple cooling towers cut off, but it's really all focused in the northern more parts of the county, because southern is mainly residential. So, this is very helpful for us. We are a wholesaler, and so we're looking at it as, seeing countywide, but also which agencies we kind of want to work with and target. And just from putting the data into the CTEM list and then adding that to this Google My Maps display to have a visualization of the data. I can see clearly here there's a huge cluster around the city of Irvine, city of Anaheim, and Orange, and that's really going to help us with targeting. So again, I looked at 880 sites that we put into the model, and out of that, 339 I confirmed had a cooling tower, and then 541 I could not confirm the presence of a cooling tower. I have a note here about includes 35 shared, so I'll get to that in a little bit. But on the right here, you can see the breakdown of the kind of facility types and categories that it consisted of. So this first number in the parentheses is just the number of sites that I looked at. So not the number of sites that had cooling towers, but the number of sites that I looked at and was in the data. So for example, education had 32 sites, and that made up 3.6% of that total 880 number. And then out of education, 47% of those had confirmed cooling towers. So most of these numbers range from about 30 to 66%. The auto pop list did have a category as other. It's kind of just these random building types. And that had a lot of sites at 409, but only 15% of them had confirmed cooling towers. So it was a lot to kind of look through. But at the same time, 15% of 400 is 60. So it still told me, 60 or more sites that had cooling towers that otherwise I wouldn't have known. So that was very helpful. And you can go to the next slide here. And this is showing the shared sites that I mentioned and that I had showing in the blue markers. So here we have 5 different buildings. 4 of them have the blue markers, 1 has the red marker. Each of these 5 buildings were in the data list, and the CTEM model, predicted would have cooling towers. And they do, but it's all shared. They all seem to be using this set of cooling towers here that the red arrows are pointing to. So this is kind of interesting and something I just wanted to note. I really only found this in the city of Irvine here in Orange County, which has a lot of newer development. But this is really good for outreach, right? It's a good target. I don't have to try and go after these 5 different buildings. You can just find, hopefully get one site manager and work with them instead of having to work with all these buildings. So that was an interesting find I had with all these shared kind of central cooling towers. Next slide. And then just to talk about the key takeaways. So this provided a lot of information that was basically non-existent before. This is information that we can share with our retailers, and I can end up, getting kind of more specifics for each agency to share that with. It's just a better understanding of the commercial water use in Orange County in general. And then again, data matters. If you can get a really good data set, you could get really good results with the CTEM model. And next slide. And so this is just kind of, looking forward, what the next steps are now that I've finished this visual kind of validation of these sites, is to find out which companies are managing these cooling towers. And specifically, we know there's some that are managing multiple sites. And so those might be great targets if you can, find one person or one company and hit many sites through them. Another is water savings estimates. So the CTEM model does give some information to the water use and potential water savings. So looking forward, I could find this number for Orange County, but I'm really interested to break it down to individual retail agency level and really help define it that way and get more specific for each agency. Working with retailers, right, it's going to be helpful to work with them. Maybe they have contacts, maybe they know a bit more about their cooling towers. Some of our agencies have recycled water, so maybe I further want to break it down to how many cooling towers we have in potable, how many I can confirm with them are on recycled water. and then again, just breaking it down, the water savings estimates to the retail agency level and help refine the estimate that the CTEM model gave me. And then hopefully all of that helps lead to some action and getting some actual water savings and reducing water use for cooling towers in Orange County. So you can go to the last slide here. This is just my contact information. So feel free to reach out to me with any questions. And thank you to everyone here today. And I'll send it back over to AWE.
Great, thank you, Sam. It was fantastic to hear both the case study from Maureen and then Sam talking through how you all have used this tool and really made the most of bringing in additional data and further refining your inventory. Great to see the examples of where you found stuff and where you didn't find some. This really highlights that there's historically been a challenge in finding where these exist to begin with. So thank you for sharing your experience. The last thing that we wanted to talk about today is our newest member offering is called the Learning Cohort. So if you can go to the next slide, please, Brad. I'm going to share a bit about what this is before we jump into the Q&A. So we're going to offer a peer learning cohort. Our first one is going to be focused here on cooling technology. So the idea would be to help this cohort use the AWE cooling technology tool. So to get started, help identify additional data sources like Sam was talking about to help further build your inventory, help utilities assess if it's a viable source to save water in your community, in your service area, and help take steps to either develop or enhance a cooling tower program, an opportunity to network and troubleshoot together, have access. We'll have various experienced pros coming to the meetings over the course of the cohort. And then ultimately you'll have a network of colleagues to lean on. So we really do want to create a network and also create a means to make our tools and our resources lead to action. So really increasing the number and the scale of projects that reduce water use and improve the effectiveness of all of our programs and services and policies that are focused on cooling technology. Next slide, please. We're hoping to have our first meeting at the beginning of the year and meeting potentially every 6 to 8 weeks over the course of about a year. We're expecting there'll be some time outside of the cohort meetings to work through either the tools or other homework on your own and then bring it back to the group. You know, while this is supposed to be educational and learning, there's also inherently some accountability to this. So we want folks to be engaged and part of this process through their time in the cohort and be able to lean on each other to drive action within their own organization too. So if this is something that's of interest to you, we have a short application that we're asking folks to fill out by Friday, December 9th, if they're interested. This is our first time doing something like this, so it'll be a little bit of a pilot. So thank you for working with us on that and providing some feedback. We do anticipate that hopefully this will help build a model for other topics in the future beyond cooling technology. So you can either scan for the application or go to the link below. And you can find out a little bit more on our website on the cooling technology resource page, or you can always reach out to us directly and ask us questions. So I will pause there and I'm going to turn it to Brad, who can help us facilitate any Q&A that have come up so far in today's webinar.
Thank you, Lisa. Okay, great presentation from all our presenters. I am right now pulling up the question and answer, and just to let everyone know, you can continue to type in questions and answers as you hear all these, but I'm just going to go from chronological order. So the first question I have says, do you have information on other sites that have made use of the 4 alternative systems? And beyond that, where can we find more information on those alternatives, including local companies who have experience with them?
That's a great question. So the report, the Alternative Technologies report, has more in-depth information around each of the technologies. So you can find the more in-depth information there. I think it would be a great sort of next step to help identify where these have been utilized and where they have been utilized successfully. So that is certainly something that we could explore as a future resource as part of this project to help get farther toward action in these spaces. So great suggestion, great question.
Okay, thank you, Liesel. The next question I have is, can you share the locations identified? Orange County Health performed its own search for cooling towers with support from California State Health. It would be interesting to compare the findings between the two efforts.
Yes, I can actually. So if you want to just reach out to me, I do have it all on a file. I have it right now just on Google My Maps file, but I can download that. And I do have just the CTEM database with all the addresses. So feel free to reach out to me and we can work together on that.
Thank you, Sam. So the next question says, for the ones that were not included in the auto-populated, were they detected by just someone looking at aerial imagery? If so, how long did this take?
For the ones not included in the auto pop. So I first started with the auto pop data set and I visually inspected everything in there. And then when we added the user input list, the co-star, which I'm assuming maybe this question's talking about, I did the same process. I just visually inspected it. So I did the same process for the auto pop and the user input, but the CTEM model by itself, when you put in the user input data set, it does give a prediction on cooling towers based on like the building size and floors. So it gives you the same kind of prediction. So I really did the same process for both. And in terms of time, it definitely took some time. I started on it when I was an intern actually, so it's a great project for an intern or part-time staff member. But if you are using Google My Maps, it makes it really easy because you could just input the data there before you've even gone through and you can just zoom in to each marker. You can upload everything as an unknown and then zoom into each marker. And when you see a cooling tower or don't, you change it to a yes or no. So I guess you could probably do, 1 or 2 minutes for each site, times that by however many you have or you think you have. So I guess we had, whatever 880 times 2 minutes is how long it took. But it was a process, did over time. Don't have a great estimate on that.
I think if I could build on that, Sam, too.
Yeah.
I just want to make sure that the group understands that the auto-populated was never meant to be the actual inventory in your territory. It was just that through the research when building the regression model, they found these national databases of hospitals, of universities, of labs and oil refineries and thought, we're collecting this data. It was that data from that given point in time. Why not use it and give a starting point to the agency? So it's really only for the largest load type of facilities and may not even include all of those. You would have to look at your own industrial customers too to make sure all of those and enter those. But then the CoStar database, which you could also get maybe from your assessor's office, is just all of the real property data. So that would be offices, multifamily, health centers, all different types of facilities, and that it'll infer from there. So I just want to make sure everyone's clear on what the auto-populated versus user input tabs are in the model.
Thank you to both of you for that answer. The next question I have is, how does CTEM help with efficiency potential?
Well, I mean, there is on the results tab of CTEM, it will show you what the consumptive use and non-consumptive use is, which is the non-consumptive is your opportunity unless you're offsetting the water, the consumptive makeup water with an alternative source. So it has the total, it has that water use, and it gives you the ability to adjust the cycles of concentration at a high scale level. Let's say when the model for MODOC at the time, when the first model that we did, showed that there was about 1,200 towers in the territory that were using about 11,000 acre feet a year, 3.1 acre, 3,100 acre feet a year were for the actual non-consumptive use. And if you went from up 2 cycles, you're looking at about 639 million gallons per year in savings. So that's where it'll give you some of this high level. Is there, how many towers are in my territory? What is the water savings potential? And you can kind of play around with those numbers based on your service area.
I will also chime in on this to make a note that you can also, you can play around with cycles of concentration, and you can also play around with the varying duty factor. So how much these cooling towers are being used in your community or service area. So you could potentially address exploring savings through that. And then the CTEM tool is also in sort of a US version, as well as a version for our friends to the north in Canada. We have a version in metric. So we have two options there, depending on where you're located, to use this tool.
All right, great answers, guys. Next question on deck. Did you look into ozone technology as an alternative technology?
I would have to reference back to the full list of what the members propose for the alternative technologies. I don't think ozone was looked at as an alternative technology. The idea with alternative would be that it would be replacing a cooling tower for the onset of that. And just so I think Lisa hit on it, was that cooling towers really are an energy efficiency measure. They're obviously using water to get rid of the heat. So not a lot of the alternative technologies, in fact, none of them at this point in time, are cost effective from a existing building, and it has to be evaluated. So ozone, it could be definitely something used for existing. But I don't think it wasn't one of the four considered.
Yeah, it wasn't one of the four considered, but yeah, I'll just underscore that it could be one of the types of ways that you address water treatment to help improve your cycles of concentration.
Great, rolling through the next one. Can you briefly chat about AHU condensate water again? How do you estimate condensate water for a site?
Oh, yeah, it's a good question. So that was just one example of an alternative water source that could be used to help supplement rather than having to use potable water every time for your cooling tower. And so it's just one example where a building that has a cooling tower might also have air handling units, and the condensate that's coming off of those systems is usually very high quality water, and could be usually is located in a place that could be easily that water could be transported to where your cooling tower is and used as a supplemental makeup water source. So I don't have specifics today on how you might go about estimating how much condensate you potentially could capture off of air handling units, but we could certainly follow up with you if you send us an email.
Okay, next question. Can Sam please post contact info again? Sam, if you want to put your email in the chat, but otherwise, as a general aside, these slides will be sent out to anyone who registered, and these slides with Sam's contact info and everyone else and all the information will be on our YouTube channel and on our website again. So moving forward, has there been any success in finding cooling tower locations beyond mapping? For example, using city building permits data or cooling tower registration like New York State does?
Well,
That's a
New
good
York State
question.
was super successful. Yeah.
Yeah, go ahead, Mo.
New York State was super successful, but it came from a different driver. It came from public health and a Legionella outbreak. So, and, it was an expensive endeavor, but they did register all of the towers and do annual inspections. A lot of people get evaporative credits to their sewer department, but those are typically like, I think in LA, we estimate there's somewhere around 5,000 cooling towers. And I think that there's only a few hundred actual evaporative credit permits that are, or industrial permits. So I don't know that those lists are complete. You don't, when you build a building, have to register that it's a cooling tower. So I think it's challenging with those other sources. There's no silver bullet.
Yeah. Another example is Vancouver up in British Columbia. They have a permit system now for cooling towers, among other types of water systems, including rainwater capture. So that's certainly one that we'll be following up on and seeing how we can learn from it. I think what you highlight here is an example of what we'll hope to explore through the peer learning cohort, is exploring all the different types of other data sources that might live out there or other partners that we might explore, either getting contact information or verification from, or even maybe long-term looking at future, different policies and practices that will make this easier as new buildings come online. So maybe it's moving forward, there's a process to flag where there are cooling towers, for example. So
yeah,
it's a great question.
and there are many communities, many public health agencies that are looking at registration. So finding out if your local public health agency is considering this and partnering with them until you could have a dual sustainability and public health initiative is possible too.
Great. Next question. Are there any estimates for the total number of cooling towers in California?
I think we could run the model for every county and figure that out.
It could be done.
Yeah, definitely.
Yeah, the model is based on, at least in the US, it's based on counties. So you'd go through each county and come up with it. So it'd take a little bit of time, but you could use the tool to get there.
All right, next question. Where can we find the water quality helper? I saw mention of it in the Cooling Technologies project summary, but I could not find it in any of the documents in the Cooling Technologies section of the AWE website.
Great question. So the water quality helper is a tab. It's also a standalone tool. That's how it kind of started. It was CTEM and then a standalone tool. And then our great partners at PNNL combined them together. So it's all within the same tool. So it's going to be the last tab in CTEM is the CTEM water quality helper tab that you can use or not use. It's an optional, but it's something to explore the different constituents that might be present in your water source. And then it will help you understand how it may or may not limit the cycles of concentration potential. And then you can, better understand what's possible in your service area and what you might need to address from a water treatment perspective to improve water efficiency.
All right, next question. Do you have any similar case studies for the cooling tower audit tool and simple return on investment calculator?
So if I'm understanding, do we have case studies from using the actual audit tool? Does that sound right, Brad?
I believe so.
So the audit tool and the built-in ROI calculator that's part of it was sort of built based on the input from this whole project, as well as based on other examples of homegrown tools that have existed in other utilities of cooling tower programs. So it's kind of merging lots of different things together. The idea is it's just a starting point so others don't have to recreate the wheel here. We don't necessarily have case studies from folks using it because it's a new tool that's just now available to folks.
And just to add to that, it is a simple return on investment calculator, so it doesn't take into account things like money over time. But I have been using it here in the city of LA for several projects that I've done recently, and it's been super helpful. Just even being able to validate savings numbers coming from vendors that I ask quotes for. So, but we don't have an actual written case study about using it.
Next question. Thank you, guys. Did the electrolysis technology use a lot of power?
No, minimal power, and they did factor that into the quote that they gave the customer when they were showing the return on investment. You can find the Los Angeles Better Building Challenge has 4 cooling tower technology tech vendors that are part of a directory, which in the how-to guide, there's a link to the directory, and you can go learn a little bit more about high cycle softening, about electrochemical water treatment, about ion exchange, and trying to think about the other one. Oh yeah, and blow down recovery, reverse osmosis.
Okay. Next up, how/where from was the user input list generated?
That was, so CoStar is a commercial real estate database that you have to subscribe to. So it costs, somewhere around $700,000 a month. And with that, you can download all of the commercial properties, buildings within your service area or a given area. They kind of define those areas. So that's where that was for the MODOC, Sam's experience. But in the guide, we kind of give you ideas that maybe you could go to your property assessor's office, to your planning department, to anyone who's going to understand about real property in your service area.
Okay, and so right now I'm looking at the final question in the Q&A box. So this is my last call. If you have more questions, we have about 5 minutes left. We're still have a little bit of time to answer another question or two. And if you want to put in a question, we don't answer it, we will certainly get it back to you in our outgoing communications in the post-webinar. So reading the last question I see for now. How can we change building policies mandating that they only use newer, efficient technology?
It's a great question. And I think something we'd love to all work on is how do we sort of build better from the start, right? Is how do we help identify more efficient designs from the beginning? So I think we're kind of all ears on strategies that we might utilize for this, examples of where communities have implemented this that we can shine a light on them. Mo or Sam, do you have additional thoughts or ideas about this?
I mean, I think it's a great thing for the cohort to address because you can't just say up your cycles. It's going to depend upon local water quality. And also it's a very hard thing to enforce, which in the city of LA, their current code requires 6 cycles of concentration, but it's not what's happening in the field, and sometimes it's not possible, right? So I do think thinking about how we could best incentivize and mandate efficiency would be a great thing for the cohort to address.
All right, that is, another question just came in. Since we have a few more minutes, I'll read it. Was the cooling tower design or retrofit looked at to reduce water waste, i.e. evaporation?
No, that was really why the alternative technologies were looked at, was to reduce evaporation. So no, we didn't specifically look at technologies to reduce evaporation. But again, it might be that the cohort, part of the cohort is research and analysis of potential technologies as they're being developed.
All right, well, I don't see any more new questions in the chat. So Lisa, I will turn it back to you.
Okay, do you want to go to the last slide? I realize you've just been hanging out on this learning cohort slide, but
yep.
I just want to thank everyone for joining us today. Please reach out with any questions. Brad went over that we will be posting a recording of this and the slides to attendees. So thank you all for joining us today, and we look forward to hopefully bringing together a great group for our first ever learning cohort. And you can find all of our resources on our website, and enjoy the rest of your day. Thank you for joining us.